second. All right, folks, this meeting is being recorded and we are here. So remember, I said that Python and, for example, C or C++ and Java, Python differs from those languages in one important way. One fundamental way it is different. Could somebody remind me what that was?
Yeah, so in case of Python, you can assign, like, for example, 5 to this variable x, and then in the next one you can assign like a string to the same variable x, and it would not mind
That is,
what in.
it won't prevent. And so the preferred thing that is emerging as a best practice is, while that leads to easy code, quick code, later on, if you want people to remember or understand what you said, you may want to do this. Let's say that suppose you're defining x. Okay. You can say x int is equal to 5. So here what happens is that it doesn't actually guarantee that you can't assign potatoes to x. For example, you can still say x is equal to potatoes, and it would still work. If you did a print x, what will come out? Potatoes will come out. So in Java or C, of course, this wouldn't be. The moment you declared int x is 5, it will never let you assign potatoes to x. It's something you have to be aware of. But this is called type hinting. People have different opinions about type hinting. I know that some of my colleagues, some of the people who work in my team. So I have, for example, 3 data science teams under me. 2 of them actually like type hinting. One team will absolutely refuse to ever use type hinting. They say, oh, it clutters up the code. We like to keep the code simple and easier to read. So it's a little bit about where you stand on with that. And obviously, I respect their wishes. So, but my own preference is type hinting is a good thing. If possible, do type hinting. And I'll let you guys decide whether it's a good syntax compared to this, if this is a good syntax or not. Like, for example, let me put it here. Whether you believe the second line is more complicated than the first, especially when you declare functions and things like that, it's more important. Now, a list can be like this. Let us go through a few operations. By the way, conversions. I told you that if you want to convert a thing to another data type, like a number to a string or something like that, you give the string function. You want to convert a string to a number, you give it whatever it is. Like here, do you see these things happening? So these are called type conversions, right? You have just converted things to whatever it is that you want to convert them to. Now, what happens if you try to convert xx like xxint? Suppose I try to convert xx, which is x is potatoes. I try to convert potatoes into an integer. How many potatoes will I get? Let's see. Oh, sorry, xxint, and then I say print. Sorry, not str. Print. How many potatoes do you think will come out of this? Anybody would like to guess? Remember, x was 5. Oh, x was potatoes. Now, what do you think will happen when I run this line? Any idea, guys?
Number of unique letters in potatoes.
Let's see what happens. What happened? Invalid literal for int. In other words, it does what happens in other languages too. In Java, in C, what happens when you try to convert a string into a number? You get a number format exception of some form, isn't it? And that is what has happened. This is a value error, is an error. It has raised an exception, and it is giving you the message invalid literal for int with base 10. In other words, it has no way to convert potatoes into an integer. So it's something to remember, right? That conversions can fail, especially when you're doing a conversion to numbers. Your conversions can fail. Converting anything to a string most of the time works. I can't think of reasons when it wouldn't, but converting things from strings to integer or float, you may have issues. It may not work. So for example, 1, 2, 3, 4, apple. Now what would happen? Suppose I do this. What do you think will happen if I do apples? Once again, it will say it cannot convert one, even though part of it is a floating point, is a number, there is no way it can convert because the word apples is present. Right? That is that. Now today, remember the last time I introduced you to the F syntax, the new way of writing strings, right? So suppose you have a string, a text is equal to.
Hello, Asif.
Yes. Go ahead, please.
No, I've shared that last time's notebook with you, so if we can continue using that.
Very good. Yeah, I'll review that. Thank you. You sent it by email or you shared it?
No, this session from last time, we can open it.
Okay.
And continue writing on that. So we have one.
One single one. And how do I get to that? Hang on.
It's in the collab.
Oh, it's in the collab. Okay. Let me go to collab. Recent examples, GitHub. You have shared it on GitHub?
No, on the collab itself, shared on your email, right? That Asif at support vector.
I don't see. What's the way to see it here? I'm not that familiar.
Maybe you have to go to your email, Asif.
I have to go to my email, isn't it? Yeah, that's what I thought.
Okay, wow.
Let me go there.
No, it doesn't pop up that way. Okay.
Yes. Oh, there we go. Oh, no. I requested access from the wrong email. 1 second. Assign in as.
Okay.
Available. Okay, connected apps. Collab.
No, that's a little bit painful. I thought it shows up on Google on its own.
Collab is great for things that where it works, but it has a rather minimal nature. Oh yes, this. Thank you for. How did you get this? Because I shared it.
Yeah, I shared it in
Okay.
Slack, so I copy pasted it.
That's that. So this is it. Anyway, so I'll go back and forth between the two for one reason. So this is okay. Conditionals. So let's review this. We did assignments, x is equal to 5. Remember what we said here? The closest thing you can come to C style is this. X colon int is equal to this. Okay. And also remember that type hinting is just a suggestion. The compiler, the interpreter will not respect it. There's no compiler, the interpreter won't respect it. Conditionals, just to review last time, we learned to do conditionals, right? Suppose we say x's value is 20 and we have a condition that says, if x is between 10 and 30, print something, else print something else, right? Here we have. So if you think about it, one easy way that I suggest to people who come from backgrounds in C or C++ or Java or something like that, if you do come from that background, you should write it as though you're writing it in C or C++, and then slowly translate it. So you notice that here, if I did not have this semicolon, this would be valid C Java statement, almost. Right? Except that it will be cout or printf or something like that. Line number, would you agree that this is practically C, C++, Java, right? Some variation of it.
Correct.
And all you have to do is to make it Python in the beginning is just do this and it becomes valid Python code. And of course, if it is printf, make it print and so forth, minor cosmetic changes. And from there, you can start your journey to make it more Pythonic. Okay? I very much suggest, and those of you who are lucky enough not to know C, C++, Java, right? You can, of course, start straight with the Pythonic format. The younger people are like that. They don't know C, C++, Java quite often. They start straight with Python, and so Python looks natural to them. When they come to C, C++, or Java, they actually find it hard. They pick up, but they find it harder. Now, but for a lot of people in our generation whose staple diet was Fortran, C, C++, Java, that's certainly my story. Started with Fortran, then C, then C++. I remember writing my first line of C in 1987. That was 33 years ago in India. So obviously Python came in 1990s. So much later. So, well, that's that. So you can make it more Pythonic by removing the braces. If you look at this and this, the only difference you see is that the braces are missing, right? Unnecessary syntactic clutter has been removed. And then you can get it even more Pythonic by writing it. Do you see the progression, guys? This is beginning to look not that different from C. It just looks neater than C or Java. And then here, then yet a little bit more cleaner. Now you notice that the conditional looks more elegant. This is the way mathematicians would talk about it, isn't it? 10 is less than x is less than 30. Those of you who are familiar with mathematics, remember much of your algebra, you remember that textbooks talk about things like that. So it's beginning to look a little bit more like that. It's a lot cleaner. And then you can keep on going that. You can say, do this if this condition is true, else do this, right? So that makes it a syntax that is somewhat unique to Python. Well, maybe other languages have it, but certainly you can't do it in C or Java, C, C++, Java. And finally, you could do something that is very unusual. It says that here is a condition. If this condition is false, pick the first one. If the condition is true, pick the second one. Actually, I like this syntax because to me, this often looks like a, one-liner that, especially if you read the code the way I often feel we should read the code from right to left rather than left to right, it's very natural. If this condition is true or false, false this, true this. And then you can print it out. Do you guys remember this? Right. So this is a review. And so if you look at this syntax, it is quite a journey we have come to, starting from something like this. Right? Then we have iterations. Iterations you can do, or looping, you can do with for loop and while loop. But there is something else that is pretty elegant in Python. So here we go. Suppose you have a list here. For values in this list, you can put the square of it. So A is here and B would be something like this. 1, 2, 3, 4, 7. And you're putting the square of it here. Isn't it? And then you print the value of B. You have done this. Could we have done this with a while loop? Would somebody like to suggest a while loop for doing this? Let's do it with a while loop. While. What would you do? You would say index is equal to 0 while index is less than length of the list A. Do what? You would do the same thing. Square and you would say what you have to remember to do. Index is equal to index plus 1. There is a shortcut. You can do plus is equal to 1. Right? which but I won't do that because some of you are just getting started with Python or any programming as a first language. So you would do like this, and once you have done like this, you can still say print B. Right? Let us run this. Oops, A is not defined, of course. I had to run this. Run this also while we are at it. Run this. So now what happened? Why did we get so many of these?
We need to break or something.
So while index is less than this, index is equal to index plus 1. So let us say what happens. When index becomes the length of it, you increase it. Otherwise, what happens? I think interesting. I myself seem to be missing the fundamentals here of the while loop. I usually rarely ever use the while loop. I'm mostly use the for loop, but it's good. It will be a review for me too. Let's figure out what went wrong here. Square length is this, length of A, B. See, one way we can do that is if index is equal to length A. We could do this, but this should not be necessary.
Can't we do while index less than or equal to length of A?
Yeah.
Oh yeah, that would be the condition, I think, that I missed. Because it's the corner case. When it is equal to that, no, it's getting, oh, you know what? I know why.
Hello?
See, I have to start this all over again. So there was no problem. I just had to, remember, we are carrying this list from the past. So it is appending to the list.
Oh.
It was just appending to the list. That's all that was happening. So now, yeah, it wasn't an error. Oh, B is this and index is 0. Why is index not getting reset to 0? This is odd. Square is, oh, square is square value. So yeah, this is another silly thing here. I have to do index A times. There we go. So let's look at this syntax. What we are saying is it start with 0 first. So you look at A0. Now this is a way. What is this way? What is A0? A0 is the
First element.
A1 is 1, 2, 3, 4. So there are 5 elements. The last element has an index less than the length of the list. That is why you say it like this. This star 2 is actually a way of squaring a number. So here, there are 2 ways I did it. Here, I literally multiplied a number by itself. That is one way to square it. Another way to square it is to do star. And it is not just square. So suppose I want to do the 4th power, I can just do star 4. And as you notice, these are much bigger numbers, isn't it? So you can play with this, right? But then, while these are ways, I mean, really, it's been quite a while since I used the for loop. I don't know why. I see it in other people's code, but I tend not to myself use it. I mostly use while loop. I mostly use the for loop, but even that I tend to use sparingly. My first option is, can I get away with something called a list comprehension? Do you notice that this is, I achieve in one line what is achieved in 1, 2, 3, 4, 5, 6 lines, isn't it? And once you get used to this notation of list comprehension, it just feels more, I hope the fonts look bigger now, it feels more elegant. What it says is that for a value in A, create value times this. And by the way, here also I could have said value star 2. It would produce the same thing. Or if I want the 4th power, I could have said 4th power. Right? So it's just when there is a one-to-one mapping between an element of a previous list and an element of a new list, you can create the new list just like this. And this way is called list comprehension. So anybody wants me to explain it further, or you pretty much got the idea?
Yeah, I just have one question. Where is it getting this value for value? Like you have defined value previously?
No, you're defining it literally here. It is a dummy variable,
Oh, okay.
right?
So Asif,
Mhm. Go
But
ahead.
here you don't have
just
to use.
go ahead, Asif.
Sorry.
Go ahead,
No,
please.
sorry. Just one last question. So here you don't have to use indexing though, right? For
No,
this
so
list
indexation
comprehension.
is not there. So what happens is, one of the things that has happened in programming is, oh guys, there's one more person who wanted to join in. Sorry to interrupt you. Can I give him a call?
Yes,
Just
sure.
guys.
Sure, sure.
All right, I couldn't reach him, so we'll continue. So this is, go ahead, Aditya, your question was, where is the index coming from? See, what has happened is, over the years, people have moved away or tried to improve upon the C syntax. We are used to the, are you familiar with the C language, C, C++, Java?
Not so much. I'm familiar with Fortran where we use the
Yeah,
indexing.
Fortran. So Fortran is also similar. You declare a variable, isn't it, in the index, right?
Right.
Now, what people started doing is they started writing code like this. So, for example, in for, this would be Java code. You would say int value in A. So, what you're basically saying is take every element of A, call it value, and do something with it. Right? So, a syntax like this, when you say for value in A, it means the following. So, suppose the values are, in fact, if I go back 1, 2, 3, 4, 7, right? These are the values. So for each of these, what it is saying is in the beginning, value is equal to 1, right? Then the value is equal to 2. Then the value is equal to 3. Let us say value is equal to 4. One by one, it will go through the entire sequence. Value is equal to 5. Oh, sorry, 7. And then what it will say is that go through this loop. This is a standard Fortran loop, right? And for each of them, produce what? Value star star 4, or let me just take 2 because it's a little bit harder for me to compute the fourth power in my mind, right? So this, and that will be equal to 1, right? Then likewise this will produce, what will this produce? This will evaluate at this, once again you do value star star 2, that will evaluate to 4. Do you see?
Yeah.
Right?
Yeah.
And so you keep on going with that value star star 2 again of 3, and you will do. So basically, let me, why say value? This evaluates to 1, 2, oh sorry, 2.
3.
This evaluates to 3, and so this becomes 9. And this is how this list comprehension works. Star star 2, and this becomes, what is it, 16, and 7, 7 star star 2, it becomes 49. It's quite interesting, when you teach, you remember what things you don't use. It's interesting. I noticed that I haven't used while in a while. Okay, so good. Do you see this? And so you started with these here in one column to get these, and that becomes the new list.
Right.
That is the way to understand list comprehension, right?
Thank
Yeah.
you. Yeah.
And then the generator is the same thing.
Just on that one on list comprehension.
Yeah.
If I use like a
Mhm.
I'm just trying to find the difference between that versus if I use a map function, which map every element to
A
square
list
it, right?
comprehension is a form of map.
Okay,
If you think map reduce, it is literally a map of
I
sorts,
see.
right? And so Python has Lambda support. It's nice that you bring it up, and why don't we cover that at some point?
Okay,
Right? How do you do functional programming in Python? We'll do that.
thanks.
And a generator is nothing but the same thing with lazy evaluation. It's like like see? So in other words, it won't actually produce that list. But if you ask for values one by one, it will keep very, very lazily giving you values when you ask for it. If you actually try to traverse the list B, it will start producing the values as you traverse it, as you walk over B. Now, why would you use generators? Sometimes what happens, right? In a lot of situations, you need B as a concept, that it is a square of A. But when you actually work with it, you don't need more than 2-3 elements of B, maybe the first 2-3. So then it was somewhat useless to produce 1,000,000 values in B when you used only a few. So in situations like that, a generator is very useful, right? You notice the type of the generator. If I do it as a generator and I try to produce it, it says it's a generator. Whereas when I try to produce this thing in a list comprehension, what does it do? By the way, let me comment it out. By the way, this shortcut is there on your Jupyter. If you highlight a certain region and do control / it will put comments across all of them. So this is it. So one produces the actual values, the other only produces a generator object and not the values. So you have to print it. Then we talked about a dictionary. Dictionaries are key value pairs, lots and lots of key values, right? A key value. So here the key is a string, value is a number. So for example, how many cabbages do I happen to have in my kitchen? Let's say 2, onions 10, potatoes, lots of it, 12. And if I print it out, it's like that. How do I convert between data type? This is what you were talking
Asif,
about. Yes, go ahead.
between the generator there, the only and the list comprehension, the only difference is the braces in the syntax.
Exactly, that's all the difference. Instead of square, if you use curved braces, it becomes a generator.
Yeah, that's
It's very neat, actually. Python has, see, every language, right, has some very neat features so that if you use a language, any language properly, you will soon fall in love with that language. And take any language it is. People who do C programming, they absolutely swear by C. They feel that every other effort to improve upon C was a wasted effort. Nothing is so nice as C. Whereas if those people who do C++, they absolutely love the standard template library, STL, and all of that syntax. Then you talk to people in Java, they have their own bag of tricks and they absolutely love Java. Same true with Scala. And I mean, these are the languages I'm heavily into. And then likewise, the same is true for R and Python. You do in R and you can't for the life of you understand why people want to do anything in Python. Because the same thing you do in almost a third of the code. Right? So, well, and then you come to Python, and then Python has its own bag of tricks. So each language is lovely in its own way. Very powerful features. So that's that. So how do we convert from one to the other? We talked about it. Now, guys, you notice that I use the F notation for strings. Did you see that? If I put F before a string, it becomes a formatted string, which means that I can actually put a variable value in this curly braces. So by now you must have noticed that in Python, all these braces, like in every programming language, they all have special meaning. A square bracket is a list. A curved bracket, right? If it has quantities in it, it's a tuple, right? And tuples don't change. We'll talk about that. But here are curly braces. Curly braces are value holders in this particular case, a value of variables. So do we understand these two lines, guys? What am I doing here? I'm taking 23 and printing the value of 23. I am multiplying x marks 3 times x. We realize what would happen if I multiply a string by 3, it just repeats 3 times over. Whereas if I really want 3 times 23, I need to first convert it into an integer, right? And once I can convert it into, by the way, this is one thing that's really nice. Jupyter doesn't have as good a support, but you notice that Colab gives you the whole definition. You just mouse over it and the whole definition of the function is there, right? It's very nice actually. So we should use that and print an F, right? I think the F is not printed, but print it's a built-in function of Python. So all right, you can play with this. So you can see that the x value is the value of x. Let's try it again. 23. If you just multiply it by 3 as a string, just 23 will repeat 3 times. But if you want to treat it as a number, you need to first convert it into a number, int x. Then it becomes a number, and if you print it, it will become what you really expect, which is 69. Right? 42, again, you can convert an integer into a string, right? And you can take a integer value, y int, and multiply that by, actually here you don't need to. Y int, y was anyway an integer. Do that. So suppose I do this, 42.56. Now let's look at it. You notice that y is 42.56. So when I print it as a string, it will print 42.56. But when I take it as an integer, what happened to the integer? Yeah, actually, let me do this. Forget this. 3. What would be the integer value of y? Just 42. Why? Because it takes away the decimal parts. I just converted it to this integer. So it's basic type conversion. If it is not your first language, then type conversion will look very intuitive. But if it is the first time you're programming, then you need to spend some time making yourself familiar with type conversions. Okay. So that's that. Then we played a game last time. Make a user guess a number. You remember that? So this is a code. I won't repeat this code because we want to do new things today. But does this make sense, guys, to you? Were you guys all able to follow this code?
Yes.
Yeah, we don't need to review this. Okay. So I'll move forward. Then we'll talk, let's go back and see in the other one if I have something else. So I want to show you the old format of strings, by the way. You notice that if I have a list of numbers here, and I want to print the length of the list, I use the dot format, string dot format, and I give the value, LL being the list. Right? What has happened is, this used to be the way you'll see a lot of old Python code to be there. But with the F format coming in, you don't need to use this. You can directly use the F format. Now, given a list, you can do many operations on a list. One of the things is, suppose you wanted to reverse the list, right? In other words, you want 6 to be first, 17 to be next, 11 after that, and so forth. So how would you do that? This is the way you would reverse the list. LL dot reverse. Right? And let's see whether it actually works or not. Here we go. The length of the list is this. When you reverse the list, well, we should print the list out in the beginning. Let me print out the list. Print. Now let's use the F syntax, the new syntax. The list is Let's look at it. So here we go. The list is 1, 2, 3, 11, 17, 6. Length of the list is 6. There's 6 elements here. And actually, let me deliberately change it to something else. I don't want it to be 5. Let's say. Yeah. Length of the list is 6, makes sense. Reversing the list, you get this. How do we get reverse of the list? You say dot reverse, right? If you want to sort it, you do dot sort, right? But if you want to, when you sort it, do you notice that length of the list, that it will go in increasing order. Right? By default, it always sorts in increasing order. But if you want the opposite sorting, you want to do a descending order sort, you can say sort reverse. Right? So sort in decreasing order. Right? How do you append something to the list? We already did that in the example. You can just go on appending an element to the list. When you append an element to the list, so for example, 19. So you'll see 19 is appended to the list. Right? And what can you do to the, what you can append one list to another list. Take all elements of one list and append it to another list. So for example, here is another list. If I want to append, I can just go to the original list and I can say extend. And when you extend, what you get, do you see that you get the combination of both of those lists, right? If you want to know what is the 11th element in the list, it's very easy. You can just index. You can do index, right? Index of the, oh, sorry. If you want to know the 11th element, you'll just do list 11 in square brackets. But you can ask this question, where is 11 in the list? Like for example, in this list, where is 11? So if you really think about it, 11 is here, right? You can do that by asking this question in the list, give me the index of 11. It will return that. And when you print it out, it will say 11 is at index 2. So look at these two lines, guys. Would you agree that it is so? Index is 1. Index 1 means what position is that in?
Second.
Second position. Very good. That's where it is. Right.
So Asif, when it like we combine the two lists, is there a way to remove the duplicates?
Is there a way? That's a very good question.
So it is like using set, right? Like, so when you use set, it automatically does it. Like since we are doing it without set, so if there is a way to remove the duplicate value.
Yeah, let us see. That's a very good question. Let's explore that together. Python, let's Google it up. Python, list extend without duplicates. Yeah, there it is. It seems that a lot of people have asked this question. Let us do list of Python without duplicates. Let's see. So one obvious way is to do the set, etc. But how can we do it without set? Extend. I can use list.extend, delete list1.3. No, that is an explicit del list1, use if else. Thank you for answers. You can extract individual list from list. Well, I wouldn't be impressed with that.
Asif, how about the union? Union will keep the common one, right?
Yes, actually, why don't we try that?
Math function union, right?
Yes. Union is true for data frames. Let us see if it is true here. That's a very good thought. Why don't we try that out? Let me insert above.
R we have unique and distinct, right?
Yeah, yeah. Here we have set. We can do the same thing here. Yeah, you could do, see, here's the thing. You could do ll dot unique, right? And it will give you a number, right? Suppose you did this unique.
Yeah, two-liner.
Oh, sorry, no, it won't. Those are also part of series. It doesn't have that. What I would do is unique ll. Let's see if that works. No, I think you have to go and use set. LL. At the end of it, right, you'll have to do something very silly,
I think union should work. Yeah.
and then weird thing, which is, as you can see, you do a union, but you do a set. But let's try to do this. Let us do LL dot extend LL. Right? If we did that and we print LL, we should get literally 100% duplicates. Right? We get a lot of duplicates. Now, suppose we did this. Where are we? So this is worth checking out. And suppose we did this. Union. Is the union supported? I don't know.
Yeah, maybe it's a set thing.
Yeah, I think it's, yeah, union is not there. So the only thing that I can think of is to do it like this. LL. Like suppose, oh, sorry, where am I? I jumped somewhere else. I jumped somewhere else. Where was I here? So suppose you have LL dot extend. I'll just pretend, Anil, that it's some other list for the time being.
Okay. Yeah.
Right? Which is not the best way. I'm sure there must be a more elegant way of doing it. Length, right? LL. Terrible way, but I think it will get the work done. And LL. Let's see. Oops, none type object is not iterable. Set LL extend. So let's go over it. Oh, list set. What is this? None type object. LL seems to have disappeared. Let's go and recreate it. LL is here, dot extend. And then once we have done that, yeah, then we'll have to do this. LL is equal to list set LL. So for the time being, we seem to have reached this far, and let's try our luck. There we go. Right? There must be a more elegant way. I just don't know off the top of my head, but we can try a little bit more. Let's see if there's somebody has done a better job.
List and set do the
What's that?
of list and set in that statement. Like, what is the function?
Oh, list is just a list of numbers. It can have duplicates. A set will remove duplicates. A set inherently does not have duplicates.
Okay.
So
maybe a list comprehension with the not.
with the what?
Maybe using list comprehension and then.
Yeah. So list comprehension. Very good point. We could do it using a list comprehension. Let us do it using that by, where am I? Is this the one that we were? Range, no. Conversion between types, value. No, I was in the other notebook. 1 second here. Right, so that's a very good point that you raised. So other way that we could have done it is, let's go create, actually, let me leave this alone. This is one way of doing it. We could also have done it below using list comprehension. Let us say A is equal to 1, 2, 3. Let's say B is equal to 55, 65, 75, right? So suppose we had to do list comprehension. So what we could do is, we could do this. X is equal to, right? A value for value in A dot extend B if A list if A dot contains, I think, does the word contains exist, contains value, and B, well, B doesn't contain, A contains value and B does not contain value.
I
Right?
think we can say unique there, right? If B
Yeah.
is unique, something like that.
Right. If we could do with this comprehension. Yeah. If what should we do with if there are more than two values in it? Yeah. So if we do A extend B value in if A dot extend B dot index.
So, Qasim, sorry, Asif. So if B element is not in A, right?
That's right. Yeah, what we can do is, yeah, that is a better way actually. That's a very good way that you mentioned. Value for value in B, very good. Excellent idea. If B A, let us say not in A is supported or not, we'll find out. There it is. And let's print X. Value for value in B, no, what we'll do is A dot append value and A. Sorry, A dot append. There we go. So you guys taught me something today. Very good. With list comprehension, we did it. So Anil, there you go. And it feels logical, isn't it? To A, append a value from B only if it is not already there in A.
Makes sense. Very good.
Yeah, no, this is good. The only thing is, like, if the original list has had a duplicate value, then it won't work, right?
Then it won't work. Yes, that is true.
Okay.
So we can remember, add only.
In either case, set seems the good way to actually remove the duplicates.
That's right. This is sort of the straightforward way of doing it. But yeah, it's nice to try it out with list comprehension. Which don't.
Here's an opportunity to add a function. Merge and delete.
Yes. So there we go. Okay. So this is our loop number thing. Now, the while, etc., etc. So sometimes, it is, we'll do an exercise which is worth doing. Suppose,
So before you go there, just one question. So in these lists, why didn't you have to use the print statement? You don't need to use a print statement, right?
oh, this is very much of a Jupyter thing. Only in Jupyter this will be true. That if you give the variable name, it automatically wraps it up in a print.
Okay. Thank you.
It has to be the last line there. On the last line, if you just find a value, it will print it.
Okay.
So now, guys, I'll try to do something practical. Suppose we open a file. In my directory, I have a file called Sonnets. Let's see if it is there. Sonnets. Now, Sonnets is something I'm fond of. Long ago, though hard to believe, there was a time when I was young too. So, and I was, like, I suppose all young people, I was in love with poetry. And I used to love the Bard's poems, Shakespeare's poems. In fact, at one time I tried to memorize all of them. I used to be very fond of them. I still am very fond of them. They're wonderful poems. So these are Shakespeare's poems. I just took this text. Then this text, I will now read the text and do something practical. We'll open this file. How do you open a file By the way, this is not the best syntax, but it's the simplest syntax. Are we together? I open this file called Sonnet, and what do? I count the number of lines of text. So number of lines, initially I set it to 0. And then I say, all right, for kangaroo in text, why did I choose kangaroo? I could have chosen anything, it doesn't matter. For word in text would have been better, but I think at some point I was explaining it to people and they said, why did I use the word variable word? I could have used any variable, so I changed it to kangaroo. Right? For word in text, you just increase the line count. Does this code look easy, guys? Think over it for a moment. I'll comment it also here. Open the file. Open we open that file, then txt. Then what do? Reset a counter, initialize a counter, right? And then for every word, do what? Increment the counter, isn't it? So those of you who are finding, if you find the syntax hard, do please tell me. Print final number. Final number of lines.
Why is it line count and not word count?
Oh, at this particular, oh, sorry, you're right. Actually, it is for text in the beginning, it is actually line count. You're right. It is not the word count. It is line. Then in a line, if you again try to go after the words, then we can do a double for loop. So it is actually line. You're right. My bad there. So a text, a paragraph, or lots of paragraphs, the first thing you can get is, if you try to iterate over it, you get lines. And if you iterate over any one line, you'll get the word. Are we together now? And thanks for catching my mistake. Huh? I would have blundered on. So far, so good? Does this make sense, guys?
Yes.
Simple. We initialize the counter. So this sort of code is very, very common in Python, to write code like this. But now the question that you guys asked is literally the next question. Well, how about if I want to count the number of words? So let's run this. It did it. Right? And you can be a bit smarter if you want to just see the progress of things being printed out. You can say print dot. So what will happen now? Let's see. At every time you read a line, you print a dot. Oh, you see lots and lots and lots of dots, followed by the number, which is a bit tedious, of course. You don't want to do that. So well, we go to the words. So how would we do the words? Let's think about it. And let us say that we want to see those words also. Here again, just to illustrate, I just changed the word to kangaroo, but let's change it to what it should be, line. For line in text, let's look at this code. What do these two, this is for every line. What am I doing here? I'm saying that any text can be split into words by invoking the word split on it. Are we together?
We're making a list of the words. Huh?
Exactly. You're making a list of the words. And then, but these are the words only in the line. So what do I need to do? All these words I need to add to this list. So I am doing it for every word, I'm appending it to that. Can you think of a better way of doing it? Can you do it a little bit better? See, instead of this, what if I had done this? Let me see. So first, let's verify that this will take you there. So you agree that all these words in this new list, I can go on appending to the master list of words. Does this code make sense, guys? Right. So what I do is I break a line into words, then for every line, I break it up into words, and all the words I append to this. And then I count the number of words. And I get this. There is actually a syntax, perhaps a little bit same syntax. Let's do a slightly different way. First, let me just run it and make sure.
No, Asif sir, I have a question. Like here, the words is a list, right?
Words, the words is a list, yes. Now
So can we just append that list to this previous list?
It will be a problematic because what will happen is, you want to see what happens if you append the list. Okay, let me do this. What if we append it? Let's do that experiment. What if we append it? Let us do that. So instead of this, we say all words append. Oh, now let's see what happens. Should I run this? You notice something strange. The number of words is only 3029, isn't it? Which also happens to be the number of lines. So if you just print out these words, just this looks like a mystery, isn't it? Jay, that was you, right?
Oh, yeah.
Yeah. So suppose you print out all of these words. Let's try to print it out and see what happens. What do you notice? You get the
Oh, it's a list of lists. Okay.
Right. You get the list of lists.
Yeah, it doesn't merge it.
It doesn't do that. So now let's try another way. That didn't quite help. All words. Let's do this. I'll insert, let's try another attempt. We'll go back to the same code, this code here, and suppose I do this. For this, one question worth asking is, can I iterate over the words themselves? So can I do this? Instead of this, can I do for word in line? Append all words, append word. For line in text, for word in line, I do this. Will this work?
But if you do extend, it should work, right?
Yes, yes.
You have to indent the word in line.
Yes.
All words dot append dot word needs a
Then
indent error, I think, yeah.
that is
indent. No,
sorry, yes, yeah.
that one. Got it. Yeah.
Yeah. And when you do this, oh, the number of words is now excessively high. Here was 20,000, and now we got, well, this was too little, and I'll get rid of this one. Just delete it. This is too much. What do you think happened? If you try to inspect what happened, you'll see, and we are gradually coming to that. You know, I'm showing you all the ways that you can do. Suppose you did all this. What do you notice?
Oh, each character.
So if you iterate over a text, any string, you will get one character at a time. We don't want that.
Okay.
So I'll remove this. What we want to do is, we don't want to do this. So this won't work. It does not. It goes character by character. So now let's go to the next way, which is this. Extend. Do you notice that we do the extend here? And what do you expect here? If you do the extend, if you want to find the length of the word, this looks correct, isn't it? You get the words. You can say length of all words is correct, right? 20,701. So at the end of it, what we are saying is, instead of doing it like this, you could have used the extend. An extend syntax will give it to you. And you can even sort it if you want. How do you sort all the words? Now you sort it by this. Right? And by the way, how do you get the first few words or first few elements of a list?
Okay.
You know, it's slightly different. That you do in data frames. Here what you do is all words. Now it is the range notation. You say from where? Let us say from 0 to 5, right? See what happens. You get the first 5 words, isn't it? Except that 0 is not necessary. 0 is implicit. If you're starting from the beginning of it, it is implicit. This, right? What happens if I do something else? Suppose I do what do you think will happen now?
From the end of the list?
4 and 3, 2.
Right, it will give you the last 5 words. Do you see how it works, guys? Huh? This gave you the last 5 words. Suppose I did
Indexing.
Suppose I did this 5 minus 1. That is, start from wherever you need to start up to 5 steps, but go in this notation. What just happened? It gave you everything except, and this will keep on going out, except skip the last, the top fifth one. So, you know, this game you can play. So I'll show you something else also. Suppose you go from 0 to 10 in jumps of 2. So first of all, let's look at the first 10 elements. These are the 10 elements here, right? Then suppose I did that, but I did jumps of 2. See what happens. How many elements did you get? Just 5, isn't it? Because it's picking up only the alternate elements. Suppose I want to pick up only third element, every third element. Now how many will I get? 0, this, that. Why did I get 4? 0 to third, sixth, ninth, and 0th. Okay, it picked up the 0th also, right? So suppose I do 4. And actually, let me just, for comparison, leave this there so you guys can see what I'm talking about. Insert cell above. Words. 0, 10, in steps of 4. Let's see. Do you notice that the first one is this? Then where does the word project come from? 2, 0, 1, 2, 3, this. This is your next one. And then 1, 2, 3, 4, here, 4th element. So it keeps jumping basically, huh? It keeps jumping. 1.
You're teaching Python.
Yeah. So this is a way to jump across.
Started around 12:15, 12:13, still going on.
Sorry, what's that? So we have that. So you got the idea, guys. So in Python, one of the nice things is that, and also frustrating thing is that, sometimes the syntax can be very cryptic. So for example, this syntax, when we say, when you're new, it sounds frustrating. When you get used to it, of course, you start loving it. You wouldn't normally have thought that this will give you all the, minus 5, sorry, would give you the last few words, isn't it? Like in Java or C, you don't have this syntax. I think they're trying to introduce it, but certainly doesn't exist. That you can read a list in reverse. That's part of it. So anyway, let's get back to it. Now that we have read all the words of the sonnets, what can we do? We can find the number of unique words in sorted order. How would you find unique? Once again, you read all the words. This part is easy, guys. We have done it so far now. And then to make unique words, we use the set operation, right? And to count how many unique words are there, we find the length of it. Does this look straightforward? Guys, are you able to see my screen?
Yes.
Okay. So tell me.
Sorry, what is line dot lower function doing there?
Oh, right. Very good, very good. That is to convert any text into lowercase.
Okay.
So you don't want the word cat spelled with a capital C to be any different from the word cat in small letters, isn't it? And so it's very common that when you're counting words, the first thing you do is you either make all of them uppercase or all of them lowercase.
Okay, thank you.
Asif, say for line in text, what does line means here? Like every line?
Anyway, it's basically saying that if you iterate over text, you'll get one line of text at a time.
If you iterate over text,
you will get one line at a time.
I see. So the counting every word in that line, okay?
Yes.
Makes sense.
This is it. Yeah. So you get the unique words. Now, how many unique words are there? Right. Do you notice this is the old syntax of string? If I were to make it the modern syntax, I would say there are unique uw.count words found. And I wouldn't do all this. I'll share this notebook also, guys, as list. And you want to convert it back as list, you can do that. And here also as list. Suppose you want to print the first 100 elements. You could do it right here using F syntax. So you don't need to use the dot format syntax, which you will see in the older Python code. So this is one of the nice things with Python. See, Python is evolving fast. The last time I remember giving this explanation, I think it's been a year or so. At that time, the F syntax was still new. And now F syntax is pretty much well established. So you see this, guys. Now, suppose I give you this task, find the frequency of the words and print the 10 most frequent words. Now, this is getting complex. By the way, this is a typical interview questions I ask people in India when I'm hiring talent. And I'll ask them how much programming experience you have. They'll assure me they have 6-7 years experience. And the same used to be true here also, though these days almost all programmers are hired in India. And here also, when I would interview people, I would ask these typical questions as a starter to weed out people. And they would have done years of enterprise software development and so forth. But you say, go find the number of unique words. And right away, they would have difficulty writing. Barely 20% of the candidates would survive. Less than that would survive even a basic test like this, find the unique words in a sorted order. Right? So now, if you were to find the frequency, oh yeah, we forgot the sort. Somewhere in there, we should do the sort. A unique word set, object, sort. Sorted. We would do that. How would you find the frequency? So now we're having it in the right frequency. Okay, words, top 10 most frequent words. How would you do that? Let's again go back to, all words.sort is already, all words.sort. Okay, so far this much is easy, guys. What have we done so far?
Asif, when you said sorted in text, how does it sort? Like numbers I understand, ascending, descending.
Oh, alphabetical. by alphabetical order.
Does it sort only the words in alphabetical order, the letters in words too?
Letters and words. So what happens is that it's called the lexicographic order. So the word apple, right,
Okay.
and abacus. So abacus will come before apple because A, B, like first the A matches, then B is before P. So abacus will come before apple
Okay, thank you.
in that way. So now if you want to find frequency, what do? We just need to maintain a dictionary, isn't it? Remember guys, a dictionary. You take a word, if the word is there in the dictionary, you increase its count. Otherwise, you set it's the first time you encountered the word and you set its frequency to 1. Does this make sense, guys? So let's take an example. Suppose frequency dictionary does not have the word abacus, right? Then add it to the dictionary value with key abacus value. Would you agree? This is what we can do. And if the word is there, if the word, say, well, these are Shakespeare's sonnets, so perhaps the word heart should appear many, many times. Encounter it again, then what do? Then increment its value, right? Isn't it? You would increment its value. So that's what we are doing. If the word is already there, let's say the word heart is already there, found in the in your dictionary, because you have encountered it before, all you do is you increase its count by 1. Otherwise, you haven't encountered that word, add it to the dictionary and set the count to 1. Do you think your frequency counter will do the job, guys? Isn't it? And then all you do is you can tell how many elements there are. Counts is equal to frequencies dot items. It will tell you a key values for every word. What are the frequencies? You can sort it. And how do you sort? By the way, this is the use of lambda. This is something one of you were asking for MapReduce, right? So suppose you sort it. How do I sort it? I say that given a key value, sort it by key, not the value. Sort it by value, not the word, right? KV1.
No, sorted by word, not the value.
No.
I think you have to.
Value. Remember, KV, the first element of KV is 0, KV0. KV0 would be the word, KV1 would be the value. So an example of KV would be...
Yes. Word and then value.
Example of KV would be...
Abacus 7 or something, heart 9.
That's right. Something like this, isn't it? So heart, the word would be the 0th element and the value would be, because you want to sort by value and you want to sort it decreasing because you want the most frequent words. So it's quite interesting actually how elegantly you can do this. By the way, this is a pretty complex code. Let me just tell you that barely 5% of the candidates even succeed in getting through this. They can do all sorts of things. They can do data science and transformer pandas and whatnot. All the boilerplate stuff. They can even write a neural network for you. But most often they fail this test. But it is quite simple. You build a frequency table, you sort it, and then you just print it. So it says that the word the is very often used. So you would imagine that these common words would be very often used, right? Suppose you want to find out how often the word heart was used. How would you do that? You would say frequencies. That's it, right? Oh, sorry, frequency is not defined. I haven't run this. There we go. Frequencies. So it turns out that in the sonnet, the word heart is used only 31 times. Isn't that surprising that in a sonnet that contains close to 20,000 words, amongst the 20,000 words, you find the word heart used only 31 times. So you say maybe heart is not that much used. What is the word love? And
Hello?
yes, are you guys able to hear me?
Yes.
Yes, no problem.
So, 1,000 times, only 109 times the word love is used, right? So it's approximately, if you take 100, it is used less than 1% of the time, half a percent, 0.5% of the time the word love is used. Now you wonder what's going on, because Shakespeare's poetry is all about, well, if you have ever read Shakespeare's sonnets, you would realize that it is about love and feelings and all of that. I don't know. So here's one thing you will notice, that the great poets, they don't write, I don't know, my interpretation, by the way. If you listen to some cheap pop music, right? When you look at popular songs, pop songs or pop music or whatever the verbiage is used for that, they tend to be very in the face words. They seem to have the word love or heart or whatever littered in every sentence or something like that, right? But I think if you really read good deep literature, you find that people use words very carefully, and quite often they can say a lot without actually using the word. But anyway, something to think about, very tangential, but I happen to notice that there is an alternate way actually. So this looks complicated, isn't it? Oh, these many lines of code to find out the most frequent words. There is actually a simpler way to do that. You, instead of doing all the hard, see here you have done all the hard work yourself. You have done it using plain Python. But actually Python comes up with something called a counter. Do you see there is a library called collections, which has a lot of useful things because we want to find the top end quite often. In fact, the whole world of business intelligence seems to be top end. So, or rather top end appears quite frequently there. So this part is clear, guys. We are just reading the words.
Yes.
Right? There's nothing magical here, reading the words, right? And then what you do is you instantiate a counter. And to the counter, you give all the words. And then you can ask very intuitive questions. Like, for example, this, give me the 10 most common words, and it will print it out. So would you agree that these two look a lot easier than this part, isn't it? Especially when you are new to Python. This is actually not hard, but certainly this is more elegant or simpler. In just 2 minutes, you're able to do the whole thing. And so that brings in the value of all these libraries that every language has. This is true here. The same is true in Python, in Java, and so forth. All these libraries that you use all these languages that you use often, they have libraries. And libraries are your savior. They make your life easy. In fact, all of these things, like pandas and numpy and scikit-learn, they're all libraries that you use so that you don't have to write a machine learning algorithm from scratch. To write it from scratch is to do numerical programming, literally go down to primitives, to know what an optimizer is, to know how to write a loss function, and so on and so forth, to be able to do the calculus. But what do? If you remember in decision tree and all this code, we just use a couple of lines of code. You instantiate a decision tree and you just say fit it to the data. and the data exists as pandas. So libraries make your life a lot easier. And again, another reason why I would stop the learning or exercise about Python more or less here, because beyond this, we may do a little bit more, but beyond this, it gets point of diminishing returns from a machine learning perspective. How do you visualize? By the way, this was something, a basic data visualization. Right? So this code, I hope, is familiar to all of you, right? You read data into a pandas data frame, guys?
Yeah.
Right. After that, if you want to plot it, one of the nice things is you can use data frame itself to plot it. Either you can use this syntax, right? Or better still, just say df.plot dot scatterplot. Are we together? And there is one more thing happening today, these days. You can actually use a different backend to your system. So for example, if I want to use a bouquet, or I want to use Plotly, all I need to do, this is a new thing actually, let me try and make it happen. I have that syntax. Welcome to collaboratory. Yeah. I was doing it for you guys the other day. Yeah. Yes. So by default, Pandas uses matplotlib as a plotting library in the backend. If you don't prefer that, you prefer to use something else, you can actually go and change. So look at this graph, guys. You look at this graph here. Suppose you didn't want to do this. One of the things you could do is you could change the backend. You could say, suppose I say Plotly. I don't know whether I have set up Plotly on this machine or not, but we'll find out. There it is. Well, Plotly graph looks rather beautiful. It has no data in it, so something is off here. We'll have to see what that is. I'll comment this out and bring it as matplotlib. Let me try pandas bouquet. So yeah, you have to set up your environment a little bit to get this to work. Yeah, do you notice that what has happened? Do you see this new visualization that has come up, guys?
Yes.
Right? And bouquet is an interactive web visualization. So for example, you can pan into any region. Let's say you can pick, you can move around, you can make selections, you could zoom into, do you notice that I'm able to zoom into this image? So in other words, these images are not static, they are dynamic, right? I can reset it, I can download this image, I can save it to something. See, here it got downloaded, right? Like this. And then you could hover.
Click on a point.
You can see any point and its value. See that? So the whole thing became interactive without me doing anything, but with me just changing the, where is that? The back end. Where is the back end gone here? I just changed the back end to pandas bouquet. Right? One second.
It just happened like that. Just change the back.
Sorry, go ahead, Mridul.
No, it just happened like that. You changed the backend and the abstraction layer came in. Wow.
That's right. That's right. Interactivity.
Wow,
By the way,
God.
most people don't know that it exists.
Oh
Most
my
people
God.
don't know. Right?
Tableau is in trouble now.
Yeah, the whole idea. See, come on. Those people have a lot of lead time, but eventually open source will catch up, right? And that's what I was trying to tell you, that the gap between production and data science is decreasing, and this is one of the examples of how it is decreasing.
And I'm You can call D3 like here as well, like something D3, or is it totally different?
Yeah, Plotly is based on D3. That's why I wanted to.
Plotly. Oh, that is very powerful. You're going to do a web page and send it to client like this, right?
Exactly.
Look at it. Okay.
So, and now I brought it back to Matplotlib. It's here. So you have the Matplotlib version, you have the bouquet version. Do you see that the same data is represented slightly differently? Right? Just by changing the backend, you can do that. Now, if you notice this, well, okay, this line also, by the way, is not necessary. So the only line that you guys, most people do, they do this and then they do this, right? The scatter plot. But if you notice, I tend to be a little bit more careful. Beyond a basic scatter plot, let me just comment all other things out before I do anything else. I run this like this. This is a basic scatter plot. Huh? And unless you set, suppose I do this, just to reset to defaults. Well, already a lot of formatting has taken place. It looks better. But generally, the vanilla Matplotlib is not very powerful. And so people often assume that Matplotlib itself is not powerful. Actually, Matplotlib is very powerful. Most of the libraries sit on top of it, and they add the extra bits of code that you forgot to add. But you can do it. For example, if I want to do this work, I can enable LaTeX true, and we have talked about it. It significantly improves the quality of the code. And let's say that I have it here, X. Let's do it interactively. I did it. Do you notice that this title has shown up here, and it has all your Greek symbols and so forth, right? Mathematical symbols properly put in, your x-axis, y-axis. Now you can do even better. You can say $x right long arrow. Now what happened? Oh, okay, long right arrow rather. Long right arrow. And I must do F. Oh, sorry. No, it was right long arrow. Right long arrow. What is going on? Oh, not F, R. We are still getting an error because X dollar long right arrow.
Is it double quote?
No. This is fine. There's something. Actually, is it? I always keep getting this mixed up, whether it's long right arrow or long LaTeX. Long right arrow. Okay, long right arrow. Long $X. Long right arrow. Let's say. Long right arrow. Keyword. This is.
Double slash?
No, we shouldn't need double slash. Something I'm doing wrong that I'll remember what it is. It's something very silly, like it's not. Okay. All right, I'll remove it for the time being. X here, let me just say X here. Actually, we just did it in our other notebook. Let's see what am I doing silly here.
So do you have a syntax in your river careful notebook? Or?
Right. Certainly, I have done it carefully there. Where is that river careful? River careful. Yeah. So if you look at this, yes, here we go. Oh, I need to do, no, long right arrow. Yeah, this is correct. So, all right, I'll just copy this and see what happens into our primer. Where is it? Where is the text we were dealing with? Here we go. Oh, okay, I got that. See, this is one of the limitations. No. The reason it isn't working is because here I'm doing data frame, pandas data frame dot plot dot scatter. And while I can do it on matplotlib plot, pandas data frame does not yet support LaTeX syntax. And it begins to, do you notice that I'm putting LaTeX here in this? Right, on the matplotlib itself. But when you do it on the data frames plot, df.plot.scatter, x is equal to, oh my goodness, I take it back. This is being silly. This is being terribly silly. Here I'm declaring the variables. I shouldn't be putting LaTeX here, sorry. Really silly. Okay, that explains. My apologies. See guys here, right? I'm specifying the XY axis. I'm not giving the X label. I should have noticed that. Right? So now X, do you see that X with long arrow is here? And you can do a plot Y label Y. I was trying to put it here without realizing that here it is the scatter method where I'm just specifying the data itself. I was just being silly. All right, so now we get this, right? Now this style, this thing, we can add more style to it. So what you can do is the same plot, I can set its size, you notice that what am I doing now? I'm giving it a color. I'm giving it markers. I'm increasing the transparency. I'm doing line width, right? So you can go and then I'll give you an example of what happens. Do you notice that these dots now look a little bit better, at least to me, compared to just the raw dots here? These blue dots. Yeah. Now you have this nice salmon colored dots which have transparency. So it gets, at least in my mind, it gets a little bit prettier. I don't know if you'll agree. And then you add some good labels. Right? This is the part that I was talking about. X, Y feature, response. You can say that X feature and Y is the response. Right? Again, and then you can add annotations. So suppose you want to bring home a point. This you want to show something. This is the way to annotate a figure. You see that? I say where, the XY coordinates, what is the text to put, and so on and so forth. Right? And you can put the text here, X is this. You can put another annotation. See, I put another annotation here. You can give it a nice title. This seems to be a sine wave, you see. So in other words, once you have a plot, you can spend quite some time making it professional or publication ready by playing with it, right? So guys, I'll stop here. For a reason, today happens to be my wife's birthday, and children and she are waiting downstairs with a cake.
Oh,
that's important.
Right. So let's take it up next week, guys.
Okay, where will you be putting the notebook, please?
On YouTube. Oh, you mean the notebook? Let me post it to Slack itself.
Okay, nice. Thank you.
Okay. Thank you.
All right. Was it useful, by the way?
Very
Yes,
useful.
Very useful.
I mean, this is
Very useful.
Very useful. Okay, good. Thank you. So
thank you, Asif. Yeah, wish your wife a happy birthday.
Sure.
Happy birthday, Smita.
Oh, she's downstairs with the. So let me stop the recording. Where's the stop?